Good morning, everyone, and welcome to our second day of architecting on AWS. I hope you've had a chance to have a relaxing afternoon yesterday to be ready and energized for today as well. Just to make sure we're ready to kick off the day, give me a quick sign, please, that we are here. A good morning, a thumbs up in WebEx, or anything of the sorts to to let us know that everything is working fine, audiovisual, and that we're ready to get started. That is perfect. Welcome, everyone. And let's begin nice and easy with a very brief overview of what we looked at yesterday. And we will also have a quiz as well. I think we have a hand raised. Is that a question there, Nikos, by any chance? Or it might just be the hand raised, I suppose. That might be an accidental hand raise. That's perfectly fine. But if anybody has any questions at any point, do let me know. All right. So everyone, yesterday we have explored what AWS is, where it lives, and how it generally works. We understand AWS lives in elements called regions, and regions have availability zones, which is ultimately the layer inside which we have data centers and ultimately where we get our resources from. Region and availability zones. And it is advisable that we use multi-availability zone solutions for high availability, reliability, and more. And we understand these regions do not cross state borders. Effectively, they are in the same country or state. But for that matter, it means they are in one single place. So what additional elements of the global infrastructure have we learned about? Maybe elements that satisfy decreasing latency, satisfying data governance in different perspectives, or just reducing time to access particular elements of data. So what other aspects of the global infrastructure have we explored? If you can let me know, please. So edge location, Yuchi, and if I do mispronounce the name, I do apologize. Feel free, please, to correct me as needed. So edge locations, everyone, an element to accelerate requests into AWS via different services, either CloudFront, global accelerators, and the like. Oh, Anthony, my apologies. There we are. I couldn't tell. It seems that the name has changed. No problem. Don't worry at all. I will try to remember your Anthony. We talked about the ability to bring AWS into your physical environment with an outpost. So you put it on premise, and you can get from AWS a physical bit of hardware that we call an outpost. And if you don't want to have your own on-premise solution, hopefully there is a local zone close to you. And we understand that the next discussion that we've explored through networking, a VPC would extend across all of these. The point is, we can launch compute and data across regions, local zones, and outposts, but generally, we can only take copied data to edge locations. Like we mentioned, through further learning, we could learn there are a little bit more intricacies here. We could have API gateway deployed at the edge. There is Lambda at edge. There is a little bit of compute if we need to at the edge, but not generally. You can't have an EC2 at the edge. We've talked about the various reasons why we would go for one or another. Ultimately, there is something called the well-architected framework that will define how and when we should use what. based on best practices. It's a balance, ultimately, in between 6 pillars: the operational excellence, security, reliability, cost optimization, performance efficiency, and sustainability. And Nikos having a question with copy data, how AWS is making sure they are in sync. That's one of the aspects of AWS managed services, Nikos. So with services such as CloudFront or S3 or Lambda, where we don't see the servers, we don't, at a high level, we don't have to worry about how it works under the hood because they're not meant to go into that level of depth for the administrator perspective. Now, from a more technical response, we configure the CloudFront synchronization with the origin via the time to live. And of course, there will be latency to replicate the data to one edge location here versus to one further away, but the issuing of the replication will happen overall when the time to live expires. And this is further learning here, Nikos, but there's not just edge locations, there's also regional edge caches, which are basically larger edge locations. So this can go into more detail. Whilst you can't configure the exact underlying hardware, let's see, there we go. See this diagram, Nikos? We can configure up to this point. For example, we can configure a time to live on the edge locations, and they will check the regional edge cache first before they go back to the origin to fetch data, a sort of intermediary cache check before they actually go to the origin, so to alleviate as much burden from the origin as possible. So there are things we can configure, but ultimately not the full extent because it's meant to be a bit more hands-off. Does that make sense, Nikos? That is perfect. Let me send you this link as well for further learning. And there we have it. Okay. There are various things that we can launch on AWS, and there are a couple of more elements of the global infrastructure, but we can only cover so much. And then we went on to explore AWS Identity and Access Manager. This is about handling access within AWS accounts. And we understand we get one very important resource when we get an account. Which one is that, everyone? The root user. And why is this important? All access and cannot be limited. So it has all access and it can't be taken away. Cannot be limited, absolutely. Therefore, you should ensure you add multi-factor authentication, and lastly, you shouldn't even use it. You should use something else. We should use IAM users, because IAM users can be given permissions through IAM policies. Now, very important, what does an IAM policy contain as its components? 3 crucial components. Some are optional, but these 3 are crucial. Action, effect, and resource. Absolutely. We need to define what API calls we will be talking about in this policy, whether or not they're allowed or denied, and what is the resource that we're ultimately making those API calls on. And users can have IAM policies, or quite simply, we can group them for easier management as well. And multiple users can be part of multiple groups as well, as we've seen, or we can just attach the policy to the group to give access to all the members of the group through one policy. All of this is in one AWS account, and an AWS account will also have a root user. Now, what if I don't just have one AWS account? What if I have more? Now, that's absolutely possible. We can just quite simply have multiple AWS accounts. There's nothing I have to do about that, literally just create more accounts. But can I manage these accounts in something more manageable, really? Probably not the best choice of words there, but absolutely, with something called AWS organizations. So AWS organizations, a free service intended for the management of multi-accounts. And absolutely right, I can see it in chat. Within the organization, we can group our accounts in organizational units, and OUs can also be nested as such. The benefit of OUs being we can add a document at the top of them. This document can be on an account level or on the OU level, and we call it what, everyone? A service control policy, absolutely, which is very, very, very similar to another type of document, but this is within the account level. So a service control policy does not grant permission. It's still a policy, still JSON formatted action effect resource, but it just doesn't give permissions. It limits the maximum amount of permissions, and we mentioned yesterday it's very close resembling another policy. Permission boundary, absolutely. Because they function basically under the same concepts. They do not grant permissions, they just limit the overall scope. There are other benefits to AWS organizations, such as consolidated billing, centralized management, and we've seen a few other elements such as tagging policies and backup policies and more. One extra note here that I want to show you, again as further learning, is this. And as I go to my account, let me ask you a question, everyone. Why do we have multiple accounts? Technically, quite a lot of use cases can be handled in one account from a performance perspective. There are enough resources. Managing billing more granularly, giving different access. So segmenting our solution from a security perspective, isn't it? Blast radius, Duncan, absolutely. So ultimately, we want resources launched in those accounts. For dev and separate for production, absolutely, Jacek, different purposes as well. Well, if I want to launch resources in all those accounts, well, I would have to go in each account and create those resources. If I do this through organization, I can add an AWS account, and if I create one, this is just about as much as I can configure. And if I have so many multiple accounts, I don't tend to just launch them empty and then go in and manually launch resources. I would like to have my Lambda functions, EC2s, VPCs, and more launched straight away. I would like when I launch an account for it to be provisioned like this right off the bat. Organizations by itself can't do that, but there is one more thing we can put on top here, and this is called... Does anyone know what might this be, if you've come across it? Think of it like organizations plus. So this is something called control tower. Control tower leverages organizations plus other services such as CloudFormation. We will talk about CloudFormation later today. Uses config, systems manager, and more to have a multi-account automated deployment of solution in a highly governed manner. Basically, through Control Tower, you can deploy accounts already with resources and with guardrails already in place so that your users can't accidentally do non-compliant actions. It's basically a collection, a well put together collection of other services to facilitate this a highly governed solution for multi-account environments. So if you would like to learn more about Control Tower, do let me know, but it is technically beyond the scope of our course. It is, however, quite an interesting service. Lastly, everyone, if we want more temporary-based access, we wouldn't be looking at policies per se, but we could be looking at something else. And Andrew, absolutely, if you're happy to, we can have a look at it at lunchtime or at the end of the day lab. So we can absolutely do that like we did yesterday. And absolutely, Arslan, IAM roles. Because IAM roles are a way to achieve the following. So let's say IAM role. Let's have multiple. Let's have a human signing in as a user. And we need a permission here to actually assume the role. We remember that is an API call. STS, assume role. And we assume this role. Can the user do anything by assuming this role? Not yet, Pravin. Absolutely. What are we missing? A policy. We're missing a policy on the role itself. Roles don't just randomly give out permissions. There still needs to be a policy that defines the level of access. So S3 here, EC2, well, let's keep color consistency, shall we? EC2, my apologies. There you go, S3, EC2, and RDS here at the bottom. Now, assuming this role, the user can work with S3, for example. So why are we going through roles? It's because of that interaction behind the scenes with the security token service, which generates a token for a maximum of 12 hours, configurable duration here. And the other benefit is services can also use IAM roles in order to interact with other services. But remember, it's a very, 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 it depends solution. There we are. Only now can the EC2 actually put an object into S3. How much of an it depends is this? Well, this IAM roles supported services. Whether or not a service works with an IAM role or resource-based policy or something else is in this set of documentation here. And you can see how much of an it depends is by looking at this chart. Basically, does the service support IAM roles or resource-based policies? The answer is yes, yes, no, yes, yes, partial, no, maybe, yes, partial, yes, no, partial, and so on. It really does depend. So it's best investigated on a service by service basis, but The rule of thumb is this. And I will take a lambda function here this time and an S3 bucket. If a lambda function makes an API call in that direction, it needs an IAM role with an IAM policy. On the S3 side, we can have a resource-based policy. We can have a resource-based policy here on Lambda, for example, and if API Gateway triggers Lambda, we will talk about both of these services. Then API Gateway needs a row on the fact that it's making an API call on this side. So this is what we'd be looking at in terms of that flow of permissions. But do remember, you technically need to only allow the API call in one policy, so you could either allow it here or here. The best practice is to use both or the central one. So if you have multiple APIs, it's best to have a resource-based policy on this Lambda function. Alternatively, if you have multiple Lambda functions, as such, best to have the permission managed on API Gateway because it's more centrally managed as well. But do remember, technically you can do it on both. So from a efficiency perspective, I'd approach it from a centralized way. But if you really want to deep dive security-wise, then resource-based policies here, IAM role with identity-based policy here. So there are different approaches depending on your focus. There we are. And the last bit with roles, everyone, they are also used to facilitate cross-account access. So if a user in account 1 needs to access S3 in account 2, that can't happen unless the user assumes a role in this other account. We call it cross-account access. And we have a question in chat, Joseph, referring to the earlier mention of control tower. It does sound similar to CloudFormation stacks because that's what technically it's using. So control tower is, in simple terms, nothing more than a group of services, one of which, for deployment solutions, is CloudFormation. So it's basically using CloudFormation under the hood to achieve those multi-account, multi-region deployments. Does that make sense, Joseph?
Yep, thanks.
No problem at all. All right, everyone. And after permissions, we started looking at more operational aspects by understanding networks and then compute. So, because we have a quiz next, I'm just going to very briefly mention these technologies, but we will do the review through some quiz questions. Essentially, if we want to have instance-based solutions provisioned and communicating using private IPv4 addresses, we need a collection of those via a virtual private cloud, and the collection will be called a CIDR range. That virtual private cloud will span an entire region, and it will be divided into subnets for easier handling of the network slices. Now, everyone, how many and what type of subnets do we have here? Please pay very close attention to the answer. We are not assuming anything on the screen. So from a technological standpoint, how are all these subnets? They are technically just 6 private subnets. At best, we could say blue and green, but to make them public, to make some public, better said, maybe the green ones, of course, how would we achieve that? How would we ensure we get public subnets here? We would need to place an internet gateway, absolutely, that is step 1. We would then need to implement routing, absolutely. So let's add this in place as well. Auto assign public IP, so we need to assign public IPs, that is absolutely right, but that is more for the resource itself, technically. So that's not solely to make the subnet public, but it is needed for a particular server. And there is one last step. So let's see, 10.0.0.0/16 local. So we have the side range of the VPC. Destination target. And the last one is, so we have 0.0.0/0 to internet gateway. And what is the last step? It's usually a common troubleshooting step because it's so easy to overlook when defining a new solution. Think of it like wanting to drive somewhere, and you set up your map on your phone, you go to your car, but the phone you've left in the house. So you need to associate the car with the sat nav, or in other words, the subnets with the route tables. So many times that's happened to me, wanting to drive somewhere, and I just leave the phone in my house, and then I'm sitting in the car thinking, right, I should know where I need to go. That's the same concept here. We need to associate the route table with the subnets, and that ultimately makes them public. So an EC2 provisioned here will be able to have dual communication with the internet, but one here will not. So for that, we would need something that's already been mentioned actually in the chat, and that is if this EC2 needs to talk to the internet, we need someone to give us a hand, and that is a NAT gateway. We need something to translate the requests from the private IP of the privately held EC2 into the internet by leveraging its own elastic IP, which is public static IP. We would need to have another route table there, but of course, for the internet-based target, we would not point to the IGW, but rather to the NAT gateway. And like before, we would perform these associations as well with these subnets. And therefore, these subnets are now private. A small matter here. What if your solution actually is kind of like this? Let's say, make this a little bit slower, a little bit bigger. There we go. That's not ideal. There we go. And we have a few more subnets. If these do not get associated with any subnet, we could have a distinction, sorry, with any route table with any access to the internet, we could have private subnets and protected subnets. Protected subnets basically have absolutely no access to the internet at all. Their route tables look something like this. Just the local route. And even that could actually be a smaller range for more granular access. But this is what these subnets would look like. And that is what we call protected subnets. It's a more security-focused discussion, but just an extra bit of learning avenue if you want to explore it from a security side. Where do we define the route table, Andrew? It's a specific resource on the VPC. So it's not, it's a separate element, if you will. It has its own API calls as well, part of the VPC, well, technically part of the EC2 API calls, but we won't go into that. It's essentially, let's see, there we go, route tables as well. There's a logical VPC router. We don't really interact with the VPC router itself, but with the route tables, and we can either define the existing ones. In that respect, there we are. I have quite a few. Or you can create a new one, and then you choose whether or not you associate it with a subnet. You can have route tables that are not connected, but you can't have subnets without a route table. So let's see, if I go to a subnet over here and go to route table, and I go to route table, I don't really have the option to not have a route table. Even if you try to launch a subnet programmatically without a route table association, it will fail with an error. Does that make sense, Andrew?
Yes, thank you. Yeah.
No problem at all. And Jacek, do protected subnet resources can communicate with Secrets Manager via VPC endpoints? Yes, they would be able to. So technically, we could create an interface endpoint to talk to Secrets Manager, and we would route to that VPC endpoint the traffic for those particular subnets, Jacek. But it would still not be any internet-based access. I can see the thumbs up, so that is perfect. All right. Let me get rid of this. It's just a bit of a mention, but it's a slightly messy one drawing-wise. And Bhavdeep, can we use Bastion host? Technically, yes, we can. It would be just another EC2 that you log into to further gain access into another one. It's not always recommended. Rather, you can use other aspects, such as logging in using Session Manager, much like you've done through the lab yesterday. So Bastion host is possible, but there are better alternatives.
Yeah, I mean, just wanted to understand, like a jump box, it will work in that case, right?
Yes, technically yes, but you would be setting it up in that respect. Oh, you mean to the protected subnet EC2?
Yes, to the protected from the like private one if we are jumping in.
So technically it could work, but again, it's best to use something like Session Manager as well. So Session Manager uses permission-based access, and again, through an interface endpoint, you can gain access into this EC2 without any internet at all. That is perfect. I can see the thumbs up. That is perfect. All right. Lastly, everyone, from a security perspective, we have two layers. What are they and where are they? So layer 4 of the OSI model, that is absolutely correct. But what if we ask what level on the VPC? So what do they protect? Six, Arslan, I'm not sure I know what to tie that with. So that is regarding policies, Leslie. Security groups and knuckles. So security groups will be protecting the instance-based solutions, whereas knuckles will protect the subnet, network access control lists. One of them is stateless, and the other is stateful, meaning you need one rule on the security group to go in one direction and the response is allowed by default, and knuckles are stateless, meaning you need one rule for one direction, another rule for another direction as well. And we do have a question from Jacek. So Session Manager doesn't break the no internet policy in the protected subnet. So Jacek is not a policy per se, it's just a strategy, basically. What we're referring to there is that in a protected subnet, so are you happy, Jacek, for a high-level explanation? And if you want, we can dive in deeper separately.
Yes. No worries.
That's perfect. Let me just grab this as well. Simple VPC here. And the idea is you have one subnet, public subnet, private subnet, so a route to NAT gateway, and protected subnet. This subnet has no entry to 0.0.0.0. That is why it is referred to as being private. No 0.0.0.0. Neither through Internet Gateway nor NAT. Now, of course, because of that, we can't use Session Manager straight away. So we can't just go into Session Manager and then into the EC2. Normally, we would need a interface endpoint, systems manager interface endpoint, and we would go like this, and then into the EC2 if it's defined correctly. So Elvis Session Manager VPC interface endpoint. We will cover interface endpoints briefly in the next module tomorrow. SSM there. I want to see if there's a diagram as well. There we are. This should be the one. It refers to Cloud9 environments, but still that idea. Let's see. Yep. There we are. I'm going to send you this link right here, Jacek.
Yeah, that's okay. Yeah, thank you. Thank you for explanation.
No problem at all.
That's an interesting one. We had a kind of explain what problem we had and see if that would resolve it. We've got a free IPA server which acts as its own DNS server. It lost its routing and we couldn't get to it through SSM. So maybe if we'd used that SSM interface server, we could have got to it. Yeah.
Possibly. So it is. It seems like it could have been possible. You're still using HTTPS in terms of the protocol, but of course, as you mentioned, you lost the DNS to it. I suspect publicly reachable, yes? Not.
No. So it acted as its own DNS server, so it couldn't resolve anything.
Okay.
Yeah. So interesting. I'll read that one. Sorry, digressed.
Yeah, no, absolutely. And do let me know if this results in more questions, and I'll be happy to look at this separately as well in more detail, but absolutely a way to access resources more securely. All right, everyone. A very, very high level here with VPCs. It's really just a review, and we will have a quick quiz shortly as well. But just to drive those final points home about the compute side of things, where does this come from? We understand where the EC2 lives in a subnet, in a VPC, in an availability zone. But what makes an EC2? It is part of a physical machine, so we get some hardware, absolutely. Software as well, and in terms of the AWS representations of those, we have the Amazon machine image here, the AMI, absolutely, which will contain the operating system and the applications. You will have IP address, a network card, which is called an ENI, absolutely, but more from a composition perspective, if you will. So let's say Elastic Network Interface. User data is optional, actually. An instance type, Joseph. That's how we define the hardware type. So something like a M5X large, for example, where M is the family, 5 is the generation, and X large is the size. Rows are also optional, but they are indeed possible through the instance profile as well. But these two elements are what really make the DNA of this EC2, if you will. Then this EC2 you will then use to perform various operations. It will essentially be compute. We understand that at launch time we can pass something called user data, as it's been mentioned. User data, as it's been mentioned in chat as well. And there's various elements of choice that we can do with this EC2. So here, let's have a look at some of the things that we've left from yesterday, such as the fact that if we want to log into this EC2 using, right, let's see, my PowerPoint is being a little bit naughty. There we go. So if we want to access the EC2, we can define key pairs, and in that case, we would access it over SSH for Linux-based instances or over RDP for Windows-based instances in that respect. And the way we would achieve this is by issuing a key pair where the public keys are on the AWS side and we hold the private key in that respect. Just remember, Session Manager doesn't actually need those keys. So with Session Manager, you don't need to define key pairs, and this is why this is also considered a more secure approach with Session Manager. And 1 point less to corrupt or lose or compromise. One quite important thing here about EC2s, and that's the reason why I left it for today, is the way we pay for it. So let's have a look at this. So we have an AMI that the EC2 comes from. Like we mentioned yesterday, at some point we decide to launch the EC2. That makes it enter a running state. running state until we decide to terminate it. No longer needed, it's gone, and at some point it is terminated. It has run between 12:03 and 13:09. The EC2. In this case, we pay for the time it runs, so we don't pay for this, we don't pay for this. These are technically free. And we have only paid for either 1 hour and 6 minutes or 2 hours. It depends on the operating system that the EC2 is working with. If it's a Windows, Amazon Linux, or Ubuntu, I believe nowadays, you get this kind of granularity. It's technically per second billing. If it's a Mac or Red Hat, for example, it would be a per hour billing solution. So 1 minute above the hour, and you're billed that extra hour. It may sound like an obvious statement, but you pay full price. This is on-demand billing and is very useful, especially compared to physical servers where you would purchase everything outright and you wouldn't potentially use it all the time. However, we don't always have these EC2s running just for staggered hours here and there. We may have them running for much longer. We may want to run them for, say, 24/7 and for months, maybe 1 year at a time, or maybe even 3 years. It would be nice if we managed to get some sort of discount for this level of continuity, and we can, because another option is to purchase a savings plan, and this can give you a discount of up to 72%. Meaning if the EC2 is, let's say, $10 per hour, with a savings plan, you could get it as cheap as $2.8 per hour out of those 10. But this is quite important. Let me ask you this, everyone. If you rent a house for a year, but you sleep at a hotel, do you still pay for the house? Indeed, you do. So if you purchase a savings plan and you never, ever, ever launch an EC2, you still pay this $2.8 an hour price here. So just be mindful of that aspect. What if I told you there's another option where we can get a discount of up to 90% as well? So we're talking here about 10 cents on the dollar and no contract. This is called spot instance. And if it sounds a little bit too good to be true, well, you are right to have those concerns, if you will, because it is very, very good from a pricing perspective, but it does offer a caveat. Within 2 minutes, any 2 minutes, the EC2 can be taken away. Now, let's remember where AWS resources come from. They come from physical servers that make up data centers. Let's do something like this as well. So let's say this is a data center that we have. And technically, different customers have different levels of utilization. Maybe we have one customer there, one customer here, one customer using a large amount, another tiny customer here, different levels. This coverage, this hardware is not utilized. So it doesn't make sense for us to try to just keep it at a full price. We do what retailers do with winter clothes in summer or summer clothes in winter. We put a big discount on it, but if someone needs those for more long-lived resources, for more long-lived solutions, then we may need to take that capacity back. So, is this a good solution? Well, it always depends on the use case. If you have a processing solution where you perform batch analytics, for example, or 3D rendering that you can pause or hold or export the current process of, what if we say save or export every 10 seconds? At the very worst, you would lose 10 seconds worth of processing if your EC2 does get terminated. But that processing you are able to achieve at as little as $1 out of 10 for the instance. So it can be a very good pricing model, but of course it does depend on the use case. Does that make sense, everyone, so far with these options here? That is perfect.
I've got a question, Stephen.
Absolutely. Yes, please.
So you said in the savings plan, you get a discount of up to 72%, but you still pay the regular price. Can you just clarify on that? I mean, do you get a discount after you paid? Or, I mean, how does that work?
Not the regular price. Let's say if EC2 is $10 per hour, in the savings plan, you pay this. So in other words, we will see this a little bit later on as well, but just jumping a little bit ahead to show you that aspect. When we configure auto scaling, for example, we can leverage all of these pricing options. So we will talk about auto scaling as well, but what I want to show you is this. There we are. Can you see this? When I choose how I want to pay for my instances, it only gives me the option of on-demand and spot. So full price or that discounted rate, without the contract. Technically, we purchase savings plans separately. So I would go through through savings plans or reserved instances, go through the process, pay for it, and I have the contract. If I launch an instance that matches what I have on my contract, then whatever is launched on demand gets that cost saving. So if I pay $10 an hour for a T3 large, but I've also purchased a savings plan contract, then I don't pay $10, I pay $4 or $3, however much the discount is. Does that make sense?
Yeah, thanks. Got it.
No problem at all. And Bhavdeep, isn't spot instances bid-based? It's had a slight change in how that works. It's kind of like a bid, if you will. It's more along the lines of a spot request. You define the maximum amount you want to pay, Bhavdeep, and if you have the instance at that level, so when you create a spot fleet, so if we have instances to offer at that price, there we go. So if we have instances at that price, then we receive them. If they get more expensive, then we don't receive those instances, or they get taken away. Does that make sense, Bhavdeep?
Yeah, so in that case, they are not always like 90%. It can be sometimes even higher with maybe the saving plan or whatever the instances we have purchased earlier, because these are always a bid based, and we set a parameter for that particular fleet to purchase in. So it can be more than that also or less. It's not always like 90%, right?
No, no, no. Of course, it's not. That's why I mentioned up to. That's the maximum discount you can get to, but it's not always that. Of course, it could be 50%. It could be 80%. It's varied depending on how the underlying capacity it's used. Does that make sense?
Yes, yes, yes.
That is perfect. And Andrew, launch time, is that creation or every time it stops and starts? It's the creation time, Andrew.
Okay, thank you. So it's a one-off activity. Yeah.
Exactly. There is a difference between stopping, terminating, and hibernating. So if you go EC2 life cycle, this is what it looks like in its full definition. And technically, we really only pay for this period right here. The rest are not technically being paid for, and they differ in behavior. So terminating means you give the compute capacity away for good. Stopping means you lend it back, if you will, so you don't pay when it's stopped. We'll go through that behavior shortly, but you still can get back the software and the configuration as well. And restarting it, rebooting it, just reboots the life cycle as well. But it's a different process also.
Okay, thank you.
No problem at all. Let me send you this as well. And let's see, Arslan, what about reserved instances and savings plans? So savings plans can be a little bit cheaper. So if we go into detail, Arslan, I'll give a little bit of detail if you're happy with that, and we can dive a lot deeper separately if you want to. The main idea is a savings plan is more flexible than reserved instances. So reserved instances are kind of like the previous way we used to do the contract-based solution. Reserved instances are still 1 year and 3 years, still best for 24/7 workloads. You still pay all upfront, partial, or no upfront. And you can get cost savings, I believe, just a little bit less, up to about 70% or so. Close, but not quite as much. But with savings plans specifically, you have two options as well. So with savings plans, we're talking about general compute savings plans or EC2 savings plans. So there we are. FAQs. There we are, compute savings plans and EC2 instance savings plans. The compute ones are a little bit less, 66%, but they offer flexibility across the other compute layers. And there's also SageMaker savings plans. This is more for machine learning and the like. But the idea is for flexibility here. So let's see. Compute savings plans being the absolute most flexible, essentially. Regardless of region, instance size, family, operating system, it's very, very flexible. That's the benefit with savings plans, Arslan. We still have reserved instances for a crucial reason. What if you're not 100% sure here? What if there's a good chance you won't actually go for a full year? Then, with reserved instances, you can sell them back, not to AWS necessarily, but to on the marketplace. So that there is a reason why we still have reserved instances. Does that make sense, Arslan, as to some differences? And we can dive deeper if you want to, but keeping it medium depth, if you will. And Bhavdeep, you're absolutely right. For stopping, we pay when we still pay for the storage. Yes, so that's what I mean. That's what we will cover in the storage section.
So just a question.
Sure.
On the savings plan, on the reserved instances, then, if you sell them to another customer, do they then buy the contracts off of customer A? So if it's a 3-year contract and they sold it 6 months into that, you'd buy it for 2.5 years.
Essentially, yes,
Yeah,
depending on what you find on the marketplace. So if I go to reserved instances, frame class, yep, that should be okay. Let's see what we find. So from AWS, okay, I can't find any other sellers. Let's try something like an M5. Maybe. It's not always that we met. There we are. So third party. Can you see this here? And
yeah.
Carried levels remaining exactly like you mentioned from those 3 years. And I think this isn't exactly 2.5 years as well.
I'm going to have to look at this. That's good. Yeah.
So one more question. If you have already instances running, how can you convert them to either savings or reserved? Can you do that?
So you don't need to convert anything, Praveen. It basically functions like this. Let's take our EC2. We've launched the EC2, and this EC2 is running. It's running. All these being days, let's say. Day. Different days, basically. I got it on demand on day 1. 5, 6, 7, 8, 9. On day 4, here, I purchased a savings plan or reserved instance, one of the two. From this point onwards, my EC2 gets the cost saving of, let's call it 70% here. It just starts being discounted if the instance type matches that on the contract. So if I purchased an M5 large as a reserved instance, but I launched a T3 micro, then I'm not getting the discount. But if this is an M5 large and the purchase is for an M5 large, then the moment we purchase it, we can use that reservation. And reserved instances, well, both actually can be used cross accounts as well. So you can pull together resources for reservations. Does that make sense, Praveen?
Yeah. Thanks.
No problem at all. That is perfect. And Bhavdeep, I have answered that question, I hope, at a high level, mentioning that we will see that in more detail when we look at storage. But yes, in a high level, the EC2, you don't pay for the compute, but you pay for storage.
Yeah.
And it's being stopped.
I just have a question, like where Andrew asked, like if I purchased a reserved plan for like 3 years and I have used it only for 6 months, I thought it goes as a spot instances in the marketplace rather than going again back as a either as a spot or on demand, but not as a reserved. Like I cannot be a seller, means I can provide that instance, but he cannot like take that contract from me if that is correct.
I'm sorry, Bhavdeep, I'm not sure I understand.
So if I have taken a contract from AWS for EC2 instance as an like a reserved instance for 3 years, and
Yeah.
I'm using it for 6 months, and then I put it into the marketplace because I'm not using it for next 2.5 years. That actually goes as an on-demand or a spot rather than going as a reserved, if I'm not wrong. And that contract still lies with me because I have a contract of three years with AWS for that instance, isn't it? So I sell it on market as on-demand or spot instance rather than as a reserved instance for them.
Well, what you are doing, because if you say it as on demand, really, it means the person buying it off you is just contracting an on-demand instance, and that wouldn't really give them any benefit. So you're really selling the benefits of your own contract. Now, exactly how your contract looks like with AWS after you sell it, I would have to double check. I haven't purchased one of these myself, but ultimately, before or until you can actually sell it, of course, the contract is with you, and only if a potential customer buys it off you, that's when they're also committing to that discount. So they're establishing a contract as well. Whether a contract still lies with you, I will have to double check that. But this is a way for you to essentially say, right, I don't want to be paying for them anymore. Another customer can benefit from these discounts. It wouldn't be spot because it would go against the grain to purchase something for a predefined period of time and be able to have it taken away from you as a customer.
Yeah. Okay. So yeah, maybe that is something. Yeah. I'll like if you can give me some clarity on that, or maybe if I'm interested in anything around that.
Yeah. So that's the element that I'm saying. It wouldn't be possible to sell it as spot, since spot is meant to be taken away at a moment's notice if it's needed. So if you sell the reservation, you really sell the reservation here. The customer purchasing the reservation of you is basically committing to what's left of that contract. So they're going to take the remaining payment and all the rest of it.
So at the end, I'm breaking the contract. So like it is kind of like no longer is reserved plan. So I would be built into different plan then.
You would be going and be billed in on demand, yes. If you give away the contract, I wouldn't say break because it's like an exit clause, if you will. So it's not a penalty in that respect.
Okay.
And there's one last question. So on that, so you actually set the price that you want to, if you sell it, then that effective price or that effective rate, you as the customer would set that, would you, or would AWS set that on behalf of?
So you could set it, but not bigger than the AWS going rate, because that could lead into speculation. Of course, you could just really buy everything up and then sell it at a markup. So
We were trying to become a seller over here.
Yeah, no, yeah.
Essentially, yes. So up to the point of AWS, basically.
And you define that as customer, you'd offer that at a price that you wanted to get rid of it at.
Exactly, because ultimately you might make a choice of cutting losses and those kind of situations. So perhaps you don't sell it at its actual market value, but a little bit less, so you can get rid of it quicker.
Fascinating. Okay.
All right. So let's have a look, everyone, at the next few parts here. If there is more interest on the costing side of things, do let me know. We don't really spend that much focus on it as part of this course. It's more of a touch base, but like we mentioned, if it's a deep interest, do let me know, please. Right. So one more aspect here that does influence cost, but it has more to do with where we launch our resources. Do you know where in a data center your EC2 gets provisioned? Is that something we know? So we know the availability zone, Andrew. Absolutely right. Ryan-ish. I think Ryan knows what we're about to discuss next? We choose the region, Nikos, absolutely, and the availability zone. But can we control more than that? So normally, not. Normally, we don't control more than that aspect because we deploy into something called shared tenancy. Meaning, you could have your EC2 here on a physical unit. Customer 2 can be on the next physical unit, on the same physical unit, and customer 3 as well. But for really stringent requirements from a data governance perspective, you might want to be the only tenant of a physical server. And that is where dedicated instances come into play. They will cost more, but they offer that isolation at the hardware level. The thing is, if you stop your instance and you launch a new one, afterwards, it might go here. We then isolate this hardware for you and give this as a multi-tenant piece of hardware. It's a very dynamic allocation within a data center. But this might be a problem for you as well in the absolute most stringent requirements if you have something like licenses per core or per sockets of underlying hardware level. So with the absolute most control, this is the option to go for. Dedicated hosts. This means we allocate physical infrastructure for you that will not change. If you terminate all these EC2s, still nobody will be using this physical unit here apart from yourself, even if it's completely unused. But it will come, of course, at the highest cost here because you're effectively isolating hardware from being able to be dynamically allocated. So this can also be influenced as well as how you are spreading or clustering your solution. Ultimately, what will talk faster, everyone, if we check some configuration here? So what will communicate faster, option B or option A? A faster communication will be option A, absolutely. We are talking about microseconds level of differences here, but there are differences. So this will be a faster connection at a microsecond level, but this will be a more reliable connection because they are across availability zones. And placement groups influence that. You can choose whether you want your instances placed within the same availability zone on the same on the same hardware congregated together. That will make use of the compute at the most performant level, but it means a failure might take down everything. Whereas you can spread your solution across multiple AZs, across individual pieces of hardware, and that will give you the most fault tolerance. However, you can also have a best of both worlds approach with a partition placement group, where you have basically clusters that are all part of a single solution. So it depends, of course, what you're trying to achieve. This could be a website for something like a bank or a medical solution where we really need to ensure the solution never, ever, ever goes down, or at least we offer the absolute minimal chances for that to happen. Whereas a cluster placement group would be something such as a high performance compute, maybe really fast data processing for aeronautics and aerospace calculations, for example, or stock trading solutions where you need that very precise calculation within a very short time span as well. But of course, if you need those kind of calculations as well as reliability, partition placement groups might be the best choice. Ultimately, there is flexibility in this area as well. This doesn't particularly influence cost in any way, it just influences availability and reliability. And performance, of course. And as useful as EC2s are, let me dial it down a notch here and take this part to explore it from a different perspective. And let me ask the following question. How much use have we gotten out of this EC2 time-wise? And might be a little bit vague here, so let me add some information. We had visitors to our website for 27 minutes. How much beneficial use have we gotten out of this website here? Well, one could argue having the website on, ready to take requests, it's also beneficial. But what if we don't get requests and we only get a few requests, or we only got them for about half an hour? We are really paying still for the whole hour and 9 or 6 minutes. So we really only used it for 27 minutes with a purpose. Much better, still much more efficient than a physical server, but there is still wastage. Enter Lambda. Lambda is still compute, but it is serverless. And Lambda is really just the code. You've seen how much configuration is needed for an EC2. Let me show you Lambda. So if I go to Lambda and I create the function, I'll give it a name, demo2 delete 7. Let's go with Python. I could configure a few other elements, but I don't need to. And if I hit create, 3, 2, 1, 0.5, 0 and 25, there we are. We have a Lambda function, some code that is ready to run at a moment's notice. An EC2 is code ready to run, but it takes a few more minutes to launch, and it is actually running when it's needed to run. This Lambda function is not. It's not costing me anything right now, but it is ready to run. If I invoke it, if I send a test payload here, it will run and then it will stop. So it will run, in my case, 1.5 milliseconds, and I was billed for 2. Much more precise than an EC2. So the moment Lambda runs until it stops, something happens here. It's an initialization state. We're going to call this a cold start. And then we actually run the code. And then we approximate to the highest millisecond here. And that is what we pay for. Very precise. Can I run Lambda again? Absolutely. I can just hit the test invocation again, and there we go. Another 2.5 or almost 2.5 milliseconds, billed for 3. So very precise. This is Lambda, everyone, a very precise serverless compute option. And we will have a look at it in a slightly, not too much, but a slightly more difference there. Sorry, and in a slightly more depth there after a short coffee break. But before we go on a coffee break, let's see if we have any questions as well. So Nikos has a question. Noticed during creation two architectures, AMD 64, x86 64 architecture. Is that for the EC2, I would presume, to Nikos, right? No, Lambda as well. Okay, let's have a look. Lambda is still running on physical physical hardware. We just don't configure that hardware ourselves, not to a lots of detail in that respect. It's just the architecture for your function code. It's more specifics there. Maybe you have some more architecture dependent code that you need to run. One of these will be more performant, for example. You can get more data here as well. It's not something we usually concern with too much, to be perfectly honest, Nikos. As developers, you would choose the language that you're more familiar with and really just take it from there. The architecture is, if you really want to be granular, with the hardware level performance of your Lambda function. But there we are. It appears the 64-bit one is Graviton 2 processors, and the other one is just a default architecture. So I would suspect this is probably a little bit more powerful, but I would have to check exactly. Let's see, depends on basic instruction set. There we are. So there's some more very intricate elements there as well. As far as I know, there's no difference in price here, Nikos, because the price is per lambda millisecond. So we can adjust the compute level in lambda, and that will make the millisecond be more expensive or cheaper. So if we check this with lambda, let's see. My apologies, there is a difference in price actually, Nikos, there we are. So there we are, x86 seems to be more expensive here than the ARM one as well. Marginally for a millisecond. But the important one is it's the memory that is going to drastically influence the compute level, the one that's going to drastically influence the millisecond price here. Does that make sense, Nikos? Yep, that is perfect. And Andrew, yes, there are data size limits as well. So Lambda is not meant for large processing, but more for point and shoot kind of solutions. It's meant for being precise rather than long running. And that is something we will explore at a high level shortly as well. Is that all right, Andrew? Does that make sense?
Yes, that's perfect. Thanks. Yeah.
No problem at all. Any other questions, everyone? Remember, we will have a look at Lambda shortly as well. I'm just mindful I have kept you for about an hour and 15 minutes as well. So it would be beneficial to have a coffee break, I would say. So give me a quick thumbs up if we're all okay with that, or if we have any questions, of course. That is fantastic, everyone. Thank you very much. I'll put a timer on the screen, and when we're back, we're going to briefly finalize Lambda. And I mean briefly because it's not a deep topic in this course, but we do have other courses that really dive deep into Lambda. Enjoy, everyone. I will see you shortly.